partial differentiation, a curly D is used to denote a differential coefficient in an expression containing more than one variable. Now let's look at the volume of a cylinder, for example. It says given V is equals to pi r square h, and we are asked to evaluate partial derivative of V with respect to r with h remaining constant. That's dv dr, and partial derivative of V with respect to h with r remaining constant. That is dv dh. Let's start with dv dr. We know that we are differentiating with respect to x, with respect to r of pi r square h. Now, however, in this case, our h is constant and our pi is also a constant. So instead of writing this, we can treat them as a constant. So we will write it as pi h, which is just multiplying, and r squared. So this will give us pi h multiplied by 2r is equals to 2 pi r h. Similarly, dv dh, we are differentiating with respect to h with r remaining constant. So every other variable aside of h will be assumed constant. So since we have pi r square h, this is the variable we are differentiating. Pi r square is henceforth a constant. So we can now write this as pi r square differentiating h. So they give us pi r squared differentiating h with respect to h will give us 1, and this is pi r squared. Let's take a look at another example. If z is equal to 5x raised to power 4 plus 2x cubed y squared minus 3y, and we are asked to evaluate a partial derivative of z with respect to x, partial derivative of z with respect to y. Now in this question, we can see that z is the function of x and y. So while differentiating partially with respect to x, y is assumed constant. While differentiating partially with respect to y, x is assumed constant. Therefore, let's solve. Let's evaluate partial derivative of z with respect to x. We are keeping y is kept as a constant. So since z is equal to 5x raised to power 4 plus 2x cubed y squared minus 3y. Now let's put into brackets what is kept constant. In this case, we have 2y squared kept constant, and here we have 3y kept constant. So let's rewrite this to give us 2y squared x raised to power 3, and this is 3y into 1. Therefore, partially differentiating z with respect to x, we have d dx of 5x raised to power 4 plus the constant of 2y squared multiplied by d dx of x raised to power 3 minus the constant of 3y multiplied by its differentiation of 1 with respect to x. So this will give us 20x raised to power 3 plus 2y squared multiplied by 3x squared minus 3y. Differentiation of a constant is 0. So this is 0. And our final answer is 20x cubed plus 6x squared y squared. Now let's solve dz dy, and here x is kept constant. In our question, we are given that z is equals to 5x raised to power 4 plus 2x cubed y squared minus 3y. Now, since x is kept a constant, we can put in brackets everything regarding x. And we know that 5x raised to power 4 will be multiplied by 1. Therefore, our partial derivative of z with respect to y, we have our constant of 5x raised to power 4 differentiated with y, the constant of 2x raised to power 3 differentiated with respect to y of y squared. There's no constant in this case aside 3 differentiated with respect to y of y. So we have 5x raised to power 4. Differentiation of the constant is 0 plus 2x raised to power 3. Differentiation of y squared with respect to y is 2y minus 3. Differentiation of y is 1. This nullifies to give 0, and we are left with 4x cubed y minus 3. Let's take another example. Good. Given that y is equal to 4 sine 3x cos 2t, we are asked to evaluate partial derivative of y with respect to x and partial derivative of y with respect to t. Now we can see here that y is a function of both x and t. So let's start with the y dx. So that means y, t in this case rather, is kept constant. Therefore our y is 4 cos 2t multiplied by sine 3x. So dy, partial derivative of y with respect to x, this is kept constant. However, Sine 3x is differentiated with respect to x. So this will be 4 cos 2t, and when we differentiate sine 3x, we have 3 cos 3x. And finally, we have 12 cos 3x cos 2t. Now let's take again partial derivative of y with respect to t. And in this case, our x is kept constant. Now, the given question of y is equals to 4 sine 3x cos 2t. Therefore, this is the constant. 4 sine 3x is the constant. Partial derivative of y with respect to t will therefore be 4 sine 3x, and we are differentiating with respect to t of cos 2t. And this will be 4 sine 3x multiplied by minus 2 sine 2t. And this will be minus 8 sine 3x sine 2t. In our next video, we'll be taking more examples on first order partial derivatives.